now what we're going to do is graph what they give us. Write the slope, write the y-intercept, but we're also going to say, well, down at the bottom, how is that different from the black line we're starting off with? Like, how would you describe in words how it changed? So, for example, here, you would say, okay, what's the slope on this one? For number A, letter A, you'd say it's 2, and then when you're graphing that, how do you graph that? Okay, it's 2 over 1, right? And the y-intercept, there's no number here, so that's just starting at 0 as well. So let's go ahead and graph that. Go up 2, right 1. Start at 0. Up 2, right 1. And just repeat that until you get to the end. Use a straight edge. Draw a nice straight line all the way through it. Now the question is, by looking at these, how would you describe the blue line compared to the black line? It always helps to put things in context. We did a while ago, we said like, well, X was like minutes and this is like money, right? So this would be like after 10 minutes, this person made $10, but the blue one, after 5 minutes, they made $10. Is that good or bad? That's a good thing, right? This person took 10 minutes to make $10. This person only didn't, made the same amount a lot faster. So you can see that compared to, this is y equals 2x, and this is just y equals x. What number, what made it go up faster? What caused that to happen? What's different between these two equations? Y-intercept's the same, both 0, 0. But just looking at the equations, what's different? Yeah, that's 2 and this is a 1. And this grew twice as fast. They got to $10 and twice as fast. It only took them 5 minutes. They got $10. This person took 10 minutes to get $10, same amount. So that's the kind of description we're going for, is that it grew twice as fast. Another way of saying it would be, you'd say something like y equals 2x is twice as steep, the steepness of the line. Okay, because the 2 makes everything grow twice as fast, which means it takes less time to get there. We're attaching meaning to our graphs. That's the idea. So at this point, at like 1, 1, this is at 1, 1, this is at 1, 2. At this point, it's at 3, 3, this person's at 3, 6. So it's twice as much. If we can go up further, but this one's at 5, 5, 5, the blue is already at 5, 10, twice as much. That's what the slope does to these two lines. You can see how it's twice as much from here to here as compared to here to here. Twice as much. Now we can do the same thing over here for number 2, which is only one half. Let's graph 1/2. X. What's the y-intercept again? What number's on the end? Yeah, there's no number there, so it's automatically 0. The slope is 1/2, so we can go to 0, 0. Up 1, right 2. Up 1, right 2. Repeat that over and over and over. We can even go down and left. Remember, that's the same thing because negative over negative is the same as positive. And we could do the same thing in the other direction. We don't really need that many points, showing that if you do, it does line up in a exact straight line. Okay. Right there. Now, seeing how the first one, it was y equals 2x, and that was twice as steep, what would be a good way of describing this? Now that's y equals 1/2 x. Yeah. Is half as steep, right? So if you go here, you can see, well, originally it was at 2, 2. This one's only at 2, 1. It's half as much. Half as much. So if you had to summarize this, how do you make the lines more steep? How would you make a line more steep? Yeah, exactly. Increase the slope and makes it more steep. If you want to make it less steep, you decrease the slope and it doesn't go up as much. Really just trying to point out what these values actually do to the graph. And if we start with just y equals x, the most basic graph, you can see, well, this is 1x. Well, y equals 2x is more steep than y equals 1x. And then back over here, well, y equals 1/2, right? Well, half is less than 1, so it's less steep than y equals 1x. That's all. Let's go down to number 1c. Take a look at that. What do we have for a slope here? Yeah, it's negative, which is the same as -1, which is the same as -1/1, and the y-intercept is still 0, yeah. There's no number after the x. There's no constant. So let's go ahead and graph these and see how they compare. -1/1, that's down 1, right 1. Okay. Of course, we can use any slope that's equal to -1, so you could even use like down 5, right 5. That equals -1 as well. Using a straight edge, of course. Now this should feel very familiar. I mean, it's kind of like just like y equals x, but how would you describe this relationship? Okay. Okay. So, what are some good words to describe? What do you have to do with the black line in order to be like match up with the pink line? Obviously, we have to move it, but in what way? What would need to be moved? Just make all the negatives positive and all the positive negatives. Like so, like -10 is now +10, but +10 is now -10. Okay. Someone else might have said, like, well, if you flip it, if you flip the black line, you kind of get the pink line. And that's kind of what we're going for here, is that, what's a mathematical word I know you've used before, that where you kind of flip something, or it's the same thing on both sides? Okay. reciprocal, but I'm not going to get at this. I don't know. It's like when you look in a mirror. Yeah, it's like reflected. If you think of this as the middle, it's like a reflection. So the way we're going to describe this is that y equals negative x is a reflection of y equals positive x. It's a reflection. And technically it's a reflection over the x-axis. So yeah, it flips or it reflects over. So when you have a negative, it makes all the negative numbers positive, makes all the positive numbers negative, which in effect reflects the whole graph. Everything changes to the opposite side. Everything that was negative is now positive. Everything that's positive is now negative. Everything is reflected. Okay. On number D, let's go ahead. I want you to copy the red line from here down below. Yeah, just copy it down. It's going to be y equals 1/2 x. Copy that over. And then go ahead and graph y equals negative 1/2 x. Make a prediction. What do you think it will look like based upon the last one? Y equals negative 1/2 x. The slope is negative 1/2, which means to go down 1 right 2. And still no y-intercepts, no numbers after the x. Go ahead and plot that. We'll start at 0, 0, down 1, right 2, down 1, right 2, and repeat the whole process. And what do you notice about these two? Not opposites. What's the word? Oh, reflections, yeah. You reflect. You look at this, it's reflected over the x-axis because one of them is positive 1/2 x and the other one is negative 1/2 x. So it's the same thing as it is here to the left. All the negatives are positive and all the positives became negative, which makes a reflection. Okay. Now, how is it different from the original, the black one? So we'd actually have to throw in that, well, y equals negative 1/2 x. It's kind of a combination of b and c. It's y equals negative 1/2 x is half as steep, right? Half as steep. And because it's negative, it's also, and it's reflected. It's both. It's a combination. Where'd you go? There it is. Okay. So, in general, we're trying to get at big patterns here. In general, the negative reflects positive graph. It just kind of flips it over the x-axis. All right. So, that's the first part. All right, let's move on to page 2. We're going to do something similar. It's going to be a little bit More straightforward though. I think this one's a little bit easier to follow. Once again, let's graph the y equals x. Just get it on there quickly. So it's going to go through 0, 0, 10, 10, negative 10, negative 10. Use a straight edge. And that's y equals x. Just like that. We don't need to spend too much time doing anything else. Alright, so we got y equals x on there. It does. You guys need to listen, not just look at and then say it's not that. I said graph y equals x on there. That's what I want you to do. Just like we did on the front. If you don't believe me, watch the video at home. You can hear me saying it. You need to listen. So graph y equals x, and then we'll go through and graph this and see, well, how's it different. So the slope here, of course, is the same. What is the slope? What's the slope? 1 over 1, yeah. So remember, we don't have the number in front of the x, but we know it's a 1x. We need to run, though, so we make it 1 over 1. And on this case, the y-intercept is 3. Right? It's plus 3. So this one starts at 3. So if we go through the process and use the slope, okay, up 1 over 1 repeatedly, okay, that will get us doing this, right? Take your straight edge. It'll look something like that. Right? Now you'll notice one thing right away is that these are those are parallel. What makes two lines parallel?
They never touch each other.
Okay, and then distance-wise, what's true about them? How far apart are these from each other?
They can use word for it.
How far apart are these from each other? And what is that distance? Exactly. If you look at the squares, you count them anywhere. 1, 2, 3. Exactly 3 away. Where else is there a 3 up here? Yeah. It's our y-intercept. Right. So another way of graphing this, instead of doing the normal, get the y-intercept, get the slope, you can just say, well, wait a minute, the plus 3 just moves the whole line up 3, and that's it. You don't really need to do anything else but just count 3 spaces, 3 squares up above any point on the black line. So, yeah, this point on the end, or the number on the end, how would we say that, what would we use to describe it? Okay. So we wouldn't want to say, well, it moves the line up. There's a more mathematical term. We say y equals x plus 3 is translated up 3. Okay, from y equals x. So we're just basically taking y equals x and moving it up 3 units. That's what the plus 3 does to it. And this will be how you're quizzed as well. You'll have, just a graph, and it'll ask you, how is this? You'll have a question, how is this different from y equals x? And you'll have to use the words reflection, steepness, translated. That's what you're picking up today, how to use these words properly. Eventually it'll be like, well, what does it actually mean? Okay, if it's half as steep, you made half as much money. Twice as steep, you made twice as much money, that kind of thing. So same thing, graph y equals, this time, let's graph y equals x. But instead of doing the slope and the y-intercept of everything, let's use what we found in part A and say that, well, wait a minute, this x plus 7, that's just going to be this line moved up 7. So we can take any points, like we can take some points down here and just go up 7. Pick any point on the line and just go up 7 from there. 1, 2, 3, 4, 5, 6, 7. Okay, pick another one here. 1, 2, 3, 4, 5, 6, 7. Right? And you'll notice, if it's done properly, okay, that it all lines up the same exact way as if you graphed it using the slope and the y-intercept. Just the same black line, y equals x, moved up 7. Same slope. Oh, that's another thing you can deduce here, is that if two lines have the same slope, then what? How do the graphs look? What type of lines are these again? Yeah. And it kind of makes sense. If you're making the same amount of money, you're just starting with a different amount of money. This person started with no money. After 10 minutes, they have $10. If this person started with $7 and made $1 an hour, well, after 10 minutes, they'll have 17. But they're making the same amount per hour, so their graphs are going to stay parallel. Meaning one person is never going to start making more than the other. And they're never going to have the same amount of money at all. All right, go ahead and do C and D. Go ahead and do C and D using a similar strategy. So if we graph this, y equals 2x, remember, it's how's it different from here, so you want to start with that base graph, y equals x. Start there. And then when you graph this one, okay, that's going to be starting at -3, up 2 over 1, right, repeatedly. But the way you describe this is going to be, you want to use the language like we did on the first ones. So you want to say that, this one is y equals 2x minus 3 is twice as steep and translated down 3 using that language. Okay. All right, you want to finish everything, page 3 and 4, by tomorrow.